The X-15 was a definitive technological bridge between atmospheric flight and orbital spacecraft. In 1954, the aerospace industry faced a critical data gap known as the, quote, violent hypersonic middle ground. They needed a reusable piloted vehicle to repeatedly sample the hypersonic regime and provide essential data for future space exploration. The X-15 program was a collaborative mandate. Joint program management included NACA, later NASA, the USAF, and the U.S. Navy. North American Aviation was the airframe contractor, and Reaction Motors handled the propulsion. The X-15 embraced the lifting re-entry philosophy, contrasting with Project Mercury's ballistic capsule. The X-15 offered an actively piloted glide, reusability, blended controls, and a hot structure thermal strategy. The X-15's anatomy of the hot structure was essential. At Mach 5+, it was built as a massive heat sink using materials like Inconel X-750 for the external skin and a primary frame of titanium and stainless steel. The XLR-99 was the first large-scale, man-rated, throttleable, and restartable liquid propellant rocket motor. It used anhydrous ammonia fuel and liquid oxygen, providing thrust up to 57,000 pounds. Navigating the edge of space required a synthesis of control systems. Below 100,000 feet, aerodynamic control was used. Above that, the reaction control system and inertial guidance, an ancestor of the Apollo FDLs, took over. The 10-minute hypersonic parabola began with a B-52 drop. The XLR-99 provided immediate chest-to-back acceleration, followed by a transition to vacuum flight, thermal loading upon re-entry, and a final dead-stick glide landing. The X-15 provided the, quote, bioastronautic baseline. The 12 pilots were research engineers shaping systems design, proving humans could withstand extreme launch and re-entry. 8 pilots earned astronaut wings. The program pushed the envelope in both speed and altitude. The high-speed profile achieved Mach 6.70. The high-altitude profile reached 354,200 feet, crossing the FAI Kármán line. The loss of Major Mike Adams during Flight 191 highlighted the crucible of systems integration. This forced the implementation of telemetered heading indicators and the simplification of critical flight displays. The X-15 transitioned into the high-altitude laboratory, carrying 28 dedicated scientific payloads. This included research in astronomy, solar physics, meteoritics, and Apollo materials science. The X-15 is the ancestry of the space shuttle. Innovations like control blending, the wedge-tail design, and terminal area energy management directly influenced the design of the space shuttle. From 1959 to 1968, the X-15 transformed hypersonics from a theoretical branch into a practical field. It was the definitive technological bridge, proving that a winged, reusable spacecraft was a viable reality. Like and subscribe for more videos.